Hello everybody, I'm Captain MAMGAIN. Last I had done one question on day's work in which the known position was given to you. In this, the known position has been given in the form of bearing and distance from the lighthouse instead of having the position of known itself. So here the question is the lighthouse position has been given to me and bearing and distance from the lighthouse is given. Now if it was a chart work question, it was very simple. You would have seen the light on the chart. You had the compass rose, you had taken the bearing, and whatever the distance has been given, you would make an arc, and that would be your position. So it was very simple doing it on the chart part of it. And then if he had asked you what was your set and drift, you would have plotted your DR position, you had your observed position, and from DR to observed, measuring it along the compass rose, you would get your set and drift. But in navigation, we don't have any luxury of the chart, so everything will have to be calculated. So we'll have to calculate our position once the position of the lighthouse has been given to me and the bearing and distance. In this case, he has given me the bearing and distance from a lighthouse. Now, this is the lighthouse. I have converted the compass bearing into true bearing. And to find my next position, normally we follow a track, go on a course, find out a delat and departure. Now, if I use my bearing, that is 068, which is north 68 east, as the course, my delat and departure would be north and east, as we've been saying in three-figure notation, and this should be my position. The bearing is the angle at the observer between the true north and the line joining the object. So now this is the true north and the observer is here and the line joining the object and the observer. So here if you see, I have taken the bearing as 068, but that is not the angle what it is making at the observer from north. The angle what it is making with the observer is from 0 to somewhere here, 248. But if I had taken the course, which is bang on opposite, that's 180 degrees opposite 068, instead of taking it as northeast, if I had taken it southwest 68, now my delat would be south, departure would be west, and my position. And now if I place the compass there, now you see that the angle according to the definition of bearing, this is the angle 68. What is being made at the observer between the line joining the observer and the object. So in these questions, when the bearing is being given to you, you use your reverse bearing to calculate your delat and departure to obtain your position. So this is important for you to remember that bearing always you have to use is the reverse bearing, that is bearing 180 plus minus. And this question I have been given here, and the bearing has been given, which I have converted into true. And then all these courses have been followed the next day with distances. He says at noon, he has given me a position. So this is my position, observed position according to him. Now to find out the set and drift, what is being asked in this question, I would require to have the DR position next day noon. I would have to calculate my DR position next day noon. And to calculate this, I should have something to start off with. So I should have the known position. Then only I can apply these courses and distances to obtain the delat and departure and find my final position. Now to calculate my position at noon, which was not given, only the bearing and distance was given. I use the reverse course, find out the delat departure, and convert my departure to D-long and get my mean lat and find my position. Then I find out my DR position here. Now DR position also the same way around. You find out the total course, total lat, total departure, and find out your position. Then he's asked me to find out the set and drift. Now to find out the set and drift, that is, I need my DR, so I've calculated my DR, and then I have to calculate my course and distance. For finding out my course and distance, I will get the two positions here of DR and observed position. I'll get a mean lat, which I'll convert my D long into departure and then get my course and distance. Now he had asked me to find out the final course made good, that is from noon to noon. So this would be my course made good noon to noon. Now to find out my course made good, again I use the initial position, final position, get my mean lat, convert my D long into departure, and then find out my course and distance. So if you notice here, that I'm converting here also my mean lat and then converting my D long into departure. I'm doing it here also, here also, here also, in 3-4 places I'm doing it. So if this position was really not asked, I won't go about calculating it. So I would be able to avoid this part of converting it into mean lat. And similarly, in this whole question, I can even avoid this part of it. So if I do not find out my known position because it's not been asked for, I might be able to skip out 1 or 2 steps here. Now, this question, I have solved it in 2 ways. One is, finding out the initial position, that I've used 1 and 4 here. And one is without finding out the known position and avoiding 1 and 4. So I will leave it to your judgment which way you want to do, but I'm going to show you both the ways how you go about solving this question. Now this is the question for you. The bearing and distance has been given to me, and these are the courses what have been given to me, all are compass courses. I find out my compass error, then I get my true course, and if he had asked me to find out the course and distance just made good, so the course made good, which is not the part of the question anyway, just find the course made good known to known, so it would be from here to here. So in this particular case, you won't require to know any of these positions. Straight away the question would be that you find out your total delat, total departure, and you can use this formula to obtain your course made good and distance made good. So here I have done it, and these are your delats and departures. I add up the whole thing, and I normally do it like this, that departure and delat I always make north, south, east, west, though in this case we have just departure only on one side, but as you can see delat is on either side, and then whichever has got the higher value, below that I write down the smaller value and subtract, and my final answer comes here, south. So these are the departure and delat for these courses, which I have made it like this because it's going to be continued in further calculations. This is not expected out of you, but this is only for making you all understand. Now I have the DLAT, I have the departure, and with this formula I can find out the course made good. But in this question, this is not asked. What he has given me is given me the known position, and he wants me to find out the set and drift. So assuming that this is your observed position, now your course made good would be from known to known. So now to find out this course in distance, I would be required to calculate the initial position. And to find out my set and drift, I would require the dr next known. So like I have written down here, do you really require to calculate this? Well, we can do without it, and that's what I'm going to show. And I will leave it to your judgment which way you want to do it. So let's start off with finding out the initial position. The lighthouse has been given to me. Position of lighthouse was given, bearing was given, and as I said, I will use the reverse bearing as the course. So what I do is take the bearing, add 180. This is my reverse bearing, and that would be my course in distance. And I find out the DLAT and departure for this. And my DLAT and departure for the course of 248 degrees here is 3.7, 9. Find my known position. I use the position of the lighthouse, use the DLAT, get my known position here. Find out the mean lat between this position of lighthouse and known position, which is here. And with this formula, I convert my D long, what do you call my departure into D long. The departure was 9.3 minutes. So I convert that, and that comes to 12.6. And thus D long I use here, and I get my known position. So this is my known position when I have used the position of the lighthouse to calculate my known position. So this is in position what I have got. Now I require to find out the dr position here because I have to find out set and drift. So using all these courses what I have got here given to me, and all these departures and DLATs what I have calculated, I can calculate the dr by knowing the total DLAT and total departure which is given to me here, and from the known position what I calculated, which I have written down here, I use the DLAT to get my latitude for dr, and then I calculate my mean latitude between the known position and the dr known next day, and convert my departure of 263 degrees, 263.9 minutes for the mean latitude of 42 degrees 20 minutes here, and I get a D long of 5 degrees 56.9 minutes west, and that I apply to this and get my dr known. So this is my dr known what I have calculated using the lighthouse position, finding out my initial position, and then I have calculated my dr. Now if you remember, we just calculated the DLAT and departure for this course, which is 3.7 and 9.3 here. Just showing you back again here. So you need not go into the step of finding out this. You can omit this if you want. What you got to do is take your first course. Of course, here it's the last one what I'm showing, but in the next slide it will come as the first course. Use this reverse bearing as the first course. So your first course is south, 68 degrees west, and distance is 10. Find out the delayed and departure for this course and distance, which have come up here. And then we add or subtract algebraic sum, because you might have to add or subtract depending upon the directions of your delayed and departure. That's why I put plus minus here. And find out your total delayed and departure right from the lighthouse itself. So this is your total delayed and departure from the lighthouse itself. Though you have not done this course, but you have used this bearing as the first course. Now I have the total delayed departure here. This position I am finding out without finding out the initial position. So I'm going to use the lighthouse position. So this is the lighthouse position what is being given to me here. And my DLAT 14.3 south here. So my DR next known would be 4225.3. Now in the conventional way of finding out your mean lat, converting your departure into D long. So here your departure 273.2. I convert it into D long and I get 6 degrees 09.4. And I apply this here, and that is my position for noon next day. So if you notice that the distance, the positions obtained from either of the calculations, either without finding your initial position or having found your initial position, they are the same. So you can use any of this. I prefer to use this because I don't have to convert departure into D long twice. So, but I leave it to your judgment which one you want to use. So now I have used my reverse bearing as my first course and found out my DR position. So in this procedure, what I've shown you here, I can avoid this step of converting my departure into D long by using mean lat. Now this, as I said, was the first course what I was using as a first course, and is being used for calculating my DR noon the next day. Now he wants me to find out the set and drift after I have done all the courses, completed it, and then he has given me the known position. So here the set and drift, find out set and drift is from DR to observed. What is the course from DR to observed is the set, and what is the distance between DR and observed is the distance, is the drift. So after doing all these courses, this was my DR. So I have written my DR position here and my observed position what is being given to me here, and my DLAT is north and D long is east. So its DLAT is north, D long is east, that means departure is east. So I would be somewhere here. So that is my observed position. Now the course from DR observed is my set, and the distance from DR to observed is my distance is the drift. Now you can convert your D long of 39.4 minus what has been given here, departure, for the mean latitude between these two, and you get the departure as 29.2. So here in this triangle, now you have the DLAT, you have the departure, and using the formula, you can find out the course and the distance. So here the set and drift has been found out, and that's your set and drift here, north 50.2 east, and your drift is 38 minutes. So now we have found out our set and drift. Now the next thing he is asking me to find out the course made good noon to noon. Now to find out my course made good noon to noon, that is from the position what I calculated to the observed position here, and this is my course made. So if you do it the conventional way, as we've been doing it, getting the two positions, finding out the DLAT, the D-long, and then converting D-long into departure by using mean lat, you get your departure, you have the DLAT, already you calculated your DLAT here, 13.7, and your departure, and using the formula again, you get your course and distance. So this is your set and drift. This is how you calculate your set and drift here. Alternately, as I said, I really need not have to use this position. I never calculated this position once. So alternately, what I can do, I have actually traveled from here, gone like this all the way, and then of course this distance also what I have been pushed has been done by the ship. So if I can get the total DLAT and departure on all the courses what the ship has done or has been made to do because of set and drift, I would be able to get my course and distance. So now in this case, I have not used the reverse bearing. I have not moved along the reverse bearing. So what I will do is in this table, I will remove this. I don't require this part of it because the ship has not done this. So whatever my total DLAT, D-long departure is there, would be reduced by this amount here. So this I have, I'm reducing this here. Of course, plus minus will depend upon what is the sign of the DLAT and departure. And now this is my DLAT and departure right from here to this place, right? And this is what we have calculated right in the beginning. And that is why I said that I'm going to be following it up right up here. So this is what the ship has done from noon to noon without taking into account what the position is. Then we have to get the DLAT and departure what we have done in this along this course, because this also has been done by the ship. So not physically, but with the current you have been pushed. So this course has been done by you. So on this DLAT and D-long, DLAT and departure, what was there, you will add this course and distance here. So you take your set here, your DLAT and departure, and get the total DLAT departure. Now you can see this is the total DLAT and departure what has been made by the ship following these courses right up to this place, and which is quite close to what you see here. My DLAT and departures here, 13.7 and 23.5. So it is not necessarily that you have to do it the conventional way of using this position and this position. So you just have to get rid of the first course, which was this bearing, and add the set and drift, which you have already calculated anyway. You're not doing any additional calculation, just adding it up here. And then again using this formula, you will get your course made good and distance made good. So this is your answer for the full set of question here. What has been asked to you? You have been asked set and drift and course made good and distance made good. I have just added up this. So this is how you'll be solving this question here. Now just a working summary. As I said, no need to find out your first position to calculate your initial position. You can always use the reverse bearing and distance as the first course to find out your dr. Now finding out your dr, you use all your courses, whatever is there, plus this will be included, and the total DLAT and departure can be applied to the position of the lighthouse to obtain your dr. So this step of converting your mean lat and getting your getting your departure converting to D long can be avoided here. And to find the set and drift, you always got to find out the course and distance between the observed and the dr. Always remember, from dr to observed, course and distance from dr to observed. To find course made good, you find out the departure and DLAT, what the ship has done. So what we did, we removed what we calculated for reverse and added up the course and distance of the drift and got the total DLAT departure. Using the formula, we got course and final course and distance. So it is up to you how you want to do it. You want to calculate this, you want to calculate the thing by finding, going the conventional way of having this position as well as this position and then finding out your course and distance. It's up to you. But I find that this is easier because I skip few steps. So it's up to you. I'll leave it to your better judgment. Thank you very much.